Okay, we have the formula right here for the area of a triangle. It does not need to be a right triangle, and it's using the sine function. So there's 3 different ways to represent it. I'm just going to focus here on the first one. 1/2 side B, side C, and then sine of the included angle alpha. Here's what I mean by that. If we look at this example here, let's see, they're giving us angle gamma. So we'll actually be using this formula. So first I'm going to draw the triangle. Anytime you're described something that you can draw, it's always wise to. 102 degrees, I'm going to put that right here. And this is angle gamma. So that means across from it is going to be side C. So that means this will be angle alpha. This can be angle beta. Angle beta has a side length of 52 units opposite it. And side alpha is going to be across, side A is going to be across from alpha. And that is 90 units long. Okay. Now, I have 2 sides and their included angles. So that's what I'm going to use. I have side A, side B, and then the sine of the included angle or the in-between angle, that's gamma. So it'll be area equals 1/2 side A, side B, sine of the included angle 102 degrees. You grab your calculator and you get, for this particular triangle, 2,288.86 square units, but it does say round to the nearest integer, so 2289, and my label, they didn't give us a label, so it's units squared. Okay, so that's how we would use this area function that has, area equation that has sine in it. It's not an area problem. This is, again, just a recap on using law of sine. So we're going to use the law of sines to figure out how high in the air this aircraft is. Okay? Here's what I know. Yes, I see a big triangle. I also see 2 smaller ones, one on the left and one on the right. Okay? I want to find this height right here that I've marked now in red. I'll label it H. The problem is the 20 miles gives us both the bottom length of the left triangle and the length of the right triangle collectively. So the 20 is really hard to utilize if we're going to try to find that height directly. So what I'm going to do instead is I'm going to use this big triangle and try to find some of the side lengths. Here's what I mean by that. Sine of angle, I'll just say gamma, okay, over 20 miles corresponds or is equivalent to sine of 35 degrees over side A. Now, I do know that angle because all the angles in the big triangle have to add up to 180 degrees. So that airplane underneath it, 180 minus 35 minus 15 gives us a 130 right here. So I can put that here. Cross multiply and divide, and we will get a side length A of 14.975. Okay. I actually might take more digits. 01722. The reason I'm taking more digits is that it is this one, and I'm not done. That is not my answer to the question. Okay. I'm now going to focus my attention on this triangle, looking for this height. So I have a right triangle. So I don't have to use law of sines. I can just say, I know that the sine of 15 degrees is equal to the opposite leg over the hypotenuse, which was 14.975, like so. Solving for h, I can get, or I will get, a height of 3.875, or in other words, 3.9, and my label will be miles for this one. So the aircraft is 3.9 miles high.